Geometric series refers to the sum of a given number of terms in a geometric sequence. Now, the formula for finding the sum of a given number of terms in a geometric progression or geometric sequence is Sn is equal to A into R raised to power n minus 1 over R minus 1 in situations whereby the absolute value or the modulus of the ratio, the common ratio is greater than 1. In other words, if the common ratio geometric series refers to the sum of a given number of terms in a geometric sequence. The formula that we use to calculate the sum of a given geometric series is Sn is equal to A into R raised to power n minus 1 over R minus 1 if the absolute value of the common ratio is greater than 1. But if it's less than 1, then we use the formula Sn is equal to A into 1 minus Rn, R raised to power n over 1 minus R. This is a situation whereby the common ratio, the absolute value of the common ratio is less than 1. So we have two examples here to drive the point home. We have to find the sum of the first 5 terms of the geometric progression. We have 1 plus 2 plus 4 plus blah blah blah. The other one is 81, 27, 9, blah blah. So starting with the first one, you realize the first term for the first one, our first term A is 1 and the common ratio is 2 divided by 1, or you can say 4 divided by 2. If you do that, you get a common ratio of 2. So this 2 is greater than 1, and therefore we shall use the first formula here, because this is the one we use when the absolute value of R is greater than 1. So we shall say Sn is equal to A into R raised to power n minus 1 over R minus 1. Our A is the first term, R is the common ratio, and n is the number of terms we are interested in getting their sum. So that means our S5, where is this 5 coming from? It's from the fact that we are getting the sum of the first 5 terms. So this subscript here, value or number, represents the term we are getting their sum. Is equal to A is 1, so it's equal to 1 into R. Our common ratio is 2, so we shall have 2 raised to power 5 raised to power 5 from the fact that we are getting the sum of first 5 terms, minus 1. As the formula states, we subtract 1 over common ratio, which is 2 minus 1. I've decided to use this color so that you can track this, the common ratio with ease. So if you simplify that, remember 2 raised to power 5 means 2 times 2 times 2 times 2 times 2, and that gives us 32. So that will be simplified to 1 into that 2 minus 1 over 2 minus 1 gives us 1. And that one, if you simplify it, you'll get 1 into that 2 minus 1 gives us that 1 over 1, and that gives us that 1 as the answer. So if you add the first 5 terms in this sequence, you'll get an answer of that 1. For the second one, you realize our first term is 81, and the common ratio is 27 divided by 81. So for the second one, as I've said, the first term is 81, and the common ratio is 27 divided by 81, which gives us 1 over 3. this 1 over 3 is less than 1, and therefore we shall use the second formula here. So we shall say Sn is equal to A into 1 minus r raised to power n over 1 minus r, which is equal to 8 to 1. This is our first term. Our first term is 8 to 1 into 1 minus r. Our common ratio is a third. So we shall have a third raised to power n. N is the sum of the terms we are looking for, which is 5. So it will be 1 over 3 raised to power 5 over 1 minus r. That means 1 minus a third. If you do that, that will simplify to 81 into 1 minus a third raised to power 5 is 1 over 243 over this. When you simplify this, you get 2 over 3, the denominator. 1 minus 1 over 243 will give you 242 over 243. So we shall have this simplified to 81 into 242 over 243 divided by the denominator 2/3. That's equal to 81, and then times 242 over 243. And because we cannot be able to divide by a fraction, we change the division or the over sign to a multiplication as we introduce a reciprocal of this. So it will be times 3 over 2, and that one simplifies to 121.